Okay, this is the first video I'm going to do on tangents to circles. Okay, just a few things to remember before I get into these questions. Remember, if the radius of a circle equals the distance between the centre of the circle and the point where the tangent hits the circle, then the line is indeed a tangent to the circle. So what I mean by that is, if we have a circle, a tangent, well, if the radius, so from here to here, is the same as the distance between that point to that tangent, a perpendicular distance, okay? If they're the same, then I can say that point, that line here is a tangent to that circle, okay? Also, any line parallel to ax plus by plus c equals 0 is ax plus by minus or plus k. So what I mean by that is, let's say I had the equation 2x plus 4y plus 5 equals 0. Well, a line parallel to this would be 2x plus 4y plus or minus any number. Okay, so we'll call it k. It can be plus or minus any number. Really, it should be plus or minus. Okay. Likewise, any line perpendicular to ax plus by plus equals 0 is bx minus ay plus, and again it should be plus or minus k. So what I mean by that is, well, if we have our line 2x plus 4y plus 5 equals 0, perpendicular line to that then would be, based on our information of this, would be bx, so that would be 4x minus 2y plus or minus any number k equals 0. Okay. The main one really to know though is this and this. Okay, you might get away with not knowing this. Okay, so in this question it says, show that the line x plus 6y minus 9 equals 0 is a tangent to the circle x squared plus y squared minus 4x plus 10y minus 8 equals 0. Okay, so it's just a quick sketch here, right? We have a circle, we'll draw a bit better than that. We have a circle, and we know the equation of that circle. We also have a line, okay, it's a tangent, so it hits at one place. Okay. And we want to show that that line is indeed a tangent. Right, here's what I'm going to do. If you look back here, there. Okay, look at point 1. If the radius of the circle equals the distance between the centre of the circle and the point where the tangent hits the circle, then the line is indeed a tangent to the circle. Okay, so if I can find the radius of this circle, and then I can get the distance between the centre of the circle to that tangent, and if they're both the same, then I can say the line is indeed a tangent. Right. Okay, so let's get the radius of the circle. Right, well, radius of the circle is the square root of g squared plus f squared minus c. And remember, this here is 2g and this here is 2f, and that's c. So if I write down what g is, what f is, and what c is. So 2g is minus 4, so g is minus 2. 2f is 10, so f is 5. C is minus 8. So put it in here, and we get minus 2 squared plus 5 squared minus 8, which is plus 8. And if we work all that out, we get the square root of 37. So that's the radius, square root of 37. Okay. So what I'm going to do now is I'm going to try find the distance between the center of the circle and the line. The center of the circle, okay, based on this, we should know is minus g minus f. So we take out this minus 4, we have it, and we change the sign, and we do the same here. So half the 4 and change the sign, which is 2, half the 10 and change the sign, which is minus 5. So there's the center. And if I can find the distance between that center and this line, and it's the square root of 37, well then I know that line is a tangent. So the equation of the line is x plus 6y minus 9 equals 0. So this is what I'm interested in, this and this. If I can find the distance between that point, so this point and this line, and then we'll compare it against this square root of 7. Right, so getting the distance between a point and a line, well, the formula is ax1 plus by1 plus c, what's the modulus of that, all over the square root of a squared plus b squared. Right, so just to find out what a, b, c, x1 and y1 are, okay, just the way we won't get mixed up. So a is the number before the x, so that's 1. B is the number before the y, which is 6. C is that number, which is minus 9. x1 then is the 2. And here is the y1, which is minus 5. Slot it into this formula, and we'll get 1, 2 plus 6 minus 5 plus minus 9, which is minus 9, and that's all over square root of 1 squared plus 6 squared. And if we work that out, we're going to get the square root of 27. And look here, square root of 27, square root of 27. So just to finish off, I can say the square root of 27 equals square root of 27. Therefore, what's the line? X plus 6y. So x is minus or plus 6y plus 6y minus 9 equals 0 is a tangent to x squared plus y squared minus 4x plus 10y. Minus 4x plus 10y minus 8 equals 0. And there we go. Okay, next question. Find the equation of the tangent to the circle x squared plus y squared minus 4x plus 2y minus 20 equals 0 at the point 5 minus 5. Right, quick sketch. Once you sketch something, it kind of makes it more, visual, and you can make a bit more sense of it. So there's our circle, and we have a tangent to that circle. And the tangent is at the point 5 minus 5. And we want the equation of the tangent of the circle. Okay, so to find the equation we need point on the line, which we have already, 5 minus 5, and we need slope of the line, which we don't know yet. However, if I could find the centre of this circle, draw a line to that point, find the slope of this, well then I'd know the slope of the tangent would be perpendicular to the slope of that. And so all I do is get the slope of this, flip it upside down, change the sign, I'd have the slope of the tangent. If I had the slope of the tangent, I could find its equation very easily. So the first thing I need to do is find the centre of this circle. There's there's 2G, there's 2F. So I want to find the centre of the circle. Take the minus 4, take it out, divide by 2, change the sign. Minus 4 divided by 2 is minus 2, change the sign, 2. Same with this, 2 divided by 2 is 1, change the sign, minus 1. So there's the centre. Next I'm going to find the slope of this line. I'll do that by calling this x1, y1, x2, y2 and using the slope formula. So y2 minus y1 over x2 minus x1, and that will be minus 1 plus 5 over 2 minus 5, and that equals minus 4 over 3. Just in case you got confused there, actually change this. That was my x2, that was my y2, that was my x1, and that was my y1. It doesn't actually matter though, okay? You get the same answer. So there's my slope of this line. I want to find the slope of the tangent. Flip this upside down, change the sign, so I'm going to get 3 over 4. Throw that information, into the equation of a line formula, because the tangent is a line obviously. So y minus y1 equals n x minus x1. This will be x1, this will be y1. So y minus which is plus 5 equals the slope, which is 3 over 4, x minus 5. And if we work that out, we will get at the end 3x minus 4y minus 35 equals 0. So there's the equation of that tangent. Okay. Right, last question then. It says find the equations of two lines parallel to the line 3x plus 4y minus 6 is 0, which are tangents to the circle x squared plus y squared equals 25. Okay. First of all, we're talking about two lines this time, and they're parallel to this. Lines parallel to that, if we look back here, lines parallel to that, the only thing that's going to change is the last number, the C bit. Okay. So I know that lines parallel to this will look like 3x plus 4y plus or minus some number k equals 0. Right? I just have to find out what that number is. And remember, it's two lines, so there'll be two numbers. But I'll sketch it out first. So there's my circle. And there's the center of the circle. We know the center of the circle of interest is 0, 0. Why? Because of that. We know the radius of the circle equals 5 also. Right. We know there is a line. Let's just say it's here. And now the equation of that line is 3x plus 4y minus 6 equals 0. Yeah. There are two lines then parallel to this line which make a tangent with that circle. Those two lines are here. Oops. So there's one, and here's the other. And we're asking, what are the equations of those two tangents? Right, well, the first thing I know is that those two tangents are going to be in this form. 3x plus 4y plus or minus some number k equals 0. The reason I know that is because they're parallel to this, so it's going to be the same x number, the same y number, and just a difference in this. The second thing I know is that the distance from the centre of the circle to each of those lines is going to be 5. Why is that? Well, because the radius of the circle is 5, which is the distance between here, and also here, and here. So, looking at that, and we think back to our coordinate geometry of a line, if I can use the formula to find the perpendicular distance between a point and a line, and let it equal 5, because I know the distance between this here and that is 5. So if I can let it equal 5 and work back and find two values for k, that will solve my problem. So here's what we're going to be left with, or what we're going to have. So it's our formula first, ax1 plus by1 plus c over root a squared plus b squared. And we're going to let that equal to 5. Okay, let's just find out what our a, b, c, x1 and our y1 are. Well, our a is 3, our b is 4, our c, now remember we don't know what it is, that's what we're trying to find, so we just say k. And our x1, which is our point, which will be the centre of our circle, we don't know yet, but have a look up here. X squared plus y squared equals 25, that's centre 0, 0. So it will be 0, 0. Okay. Now if that wasn't a circle with centre 0, 0, we would have different numbers in this, which wouldn't make any difference. Okay. Right, let's slot in what we know then. We know a is 3, x1 is 0, plus b is 4, y1 is 0, plus c, which is k, all over square root of a squared, so it's 3 squared plus 4 squared, and that equals 5. So working that out then, we have 3 zeros are 0, plus 4 zeros are 0, plus k, all over root 3 squared is 9, plus 4 squared is 16, and that all equals 5. We then will have k over, and 9 plus 16 is 25, and square root of that is 5 equals 5. And we'll be left with then modulus of k equals, divide by 5 on both sides, we get 25. So the modulus of k is 25. But once we have a modulus, we're going to have to divide this into 2 bits. Okay. And it will be k equals plus 25, or it could also be k equals minus 25. Okay, because if this k value is the absolute value of k is 25, so therefore k could be 25 or minus 25. Right, so with that in mind, here's our two equations. 3x plus 4y plus 25 equals 0, and 3x plus 4y minus 25 equals 0. So there's the equations of those two tangents. Okay.